All right, today we're going to talk about 2.1. So this is the beginning of our proofs unit. And proofs are really just a way to think about reasoning. Like, how do you solve a problem? Why do you know it works? So just your thought process to coming up with the answer in geometry, okay? So the first thing we have here is inductive reasoning. And inductive reasoning, think of it as your conclusion, like what information you are using from different examples or different theorems to come up with your conclusion or your statement, okay? Then we have a conjecture. And a conjecture is more like a hypothesis, which you have used in science before. So it's whatever statement or conclusion you believe to be true based on any observation. So any patterns that you see, whatever that hypothesis, whatever you think is going to happen next, that's going to be your conjecture. And the last one here we have is a counterexample. So sometimes you'll have to come up with counterexamples to say like, well, this isn't true, so the opposite has to be true, that kind of thing. So just something that disproves another statement, okay? So here we have our first two examples. Write a conjecture. So look at the pattern, kind of think about what's going to happen. That describes the pattern in each sequence. Then you're going to use your conjecture to find the next item in the sequence, okay? So here I have my numbers 5, -5, 10, -20, 40. So you need to start thinking about how do I get from this number to this number? And that same pattern has to apply to the other terms. So the first thing I notice is that the numbers are changing from negative to positive, back to negative, back to positive. And I'm thinking mathematically, the only way I can really do that in one step would be to multiply that number by a negative, right? Because if I do negative times a negative, that's a positive, and that positive times a negative is a negative, and that negative times another negative gives me that positive. So I know that each term is going to be multiplied by a negative first. Then think about, what do you multiply 5 by to get 10? 10 by to get 20. 20 times what gives you 40? And hopefully you're thinking that each time you multiply by 2 to get to the next term. So by looking at this pattern, I came up with the conjecture that each term is multiplied by -2 to get the next one. Meaning if I continue this pattern and I multiply 40 times -2, that's going to give me a -80 as my next term. So my conjecture is going to be exactly that. We're going to say that we multiply each term by -2. The next term is -80. Okay, so we're just putting the math that we did into a sentence, essentially, is what's happening. Okay. Now we're going to go ahead and try number 2 here. So number 2, again, think about how do you go from here to here, and it has to be the exact same pattern going all the way through. Okay. So because these numbers are increasing so much, I know that I'm going to probably be multiplying. Now, it doesn't always have to be multiplication. In this case, it just happens that both of these problems are multiplication. But whatever the pattern is, if you add 5 each time or you subtract 10 each time, whatever it is, that's your conjecture, okay? So here, 1 times 10 gives me 10. 10 times 10 gives me 100. 100 times 10 gives me 1,000. So if I go ahead and multiply it by 10 one more time, that's going to give me 10,000, okay? So again, you want to write this in a sentence form. So you multiply each term by 10. The next term is going to be 10,000. Okay. All right, so that was a conjecture based on patterns, just numbers there. But now let's go ahead and jump into more of the geometry situation here. So write a conjecture about each value or geometric relationship. Okay, hint, draw a picture. So it's going to be very helpful that we draw a picture because in geometry, a lot of it is very visual. And before we go ahead and start this problem, we want to go ahead and think about what we have talked about in geometry so far. So think about definitions or terms that we have talked about up to this point. Okay, so for proofs, you kind of have to put all your knowledge together to see what you can conclude for these problems. Okay, so first it says angle 1 and angle 2 form a right angle. So I'm going to go ahead and draw a picture here. I know that a right angle creates 90 degrees there, and I'm going to have two angles here. One angle is going to be called angle 1, and the other angle is going to be called angle 2. So what can I come up with? What conclusion can I come up with here? Well, what does it mean to be a right angle, first of all? And hopefully you're thinking that right angles are 90 degrees, okay? So by looking at this picture and knowing that these two together form a right angle, I can say a few things about them. I can say that angle 1 and angle 2 are complementary. That word means they add up to 90. Or you can also just say angle 1 plus angle 2 equals 90 degrees. Okay, those are the conclusions you can make based on just the information that you were given. You're given two angles and you are told that they form a right angle. So use the knowledge from what we've done so far in Unit 1. Right angle means 90 degrees. 90 degrees means complementary. Put all that together and that's going to be your conjecture. Okay. Then I have angle ABC. So I have angle, I'm going to go A, B, C, and then they're going to be vertical angles, and I notice that middle letter is the same, so they're going to be sharing that vertex. That's good. I need them to do that in order for them to be vertical angles, okay? So all I know, all of that it's telling me that these two are vertical angles. And remember, vertical angles are across from each other. They're always across from each other. And so think about, what do you know for sure every single time you think about vertical angles? And hopefully you're thinking that they are congruent. So my conjecture here is that these two angles that I was given, ABC and DBE, are going to be congruent angles. And again, the word congruent means that they're going to have the same measure. So if this is 70 degrees, then this is going to be 70 degrees, okay? That you know for sure about vertical angles every single time. All right, so it's just going to depend every single time on what you're going to do. And like I said, if you draw a picture, it'll help you, and then kind of go from there. What information are you given? What do you know about that information for sure every single time? And then write your statement. So use those vocabulary words that we talked about. Think about their definitions. And really, that's all you can conclude. We're not asking you to make anything up, okay? So I go to the next page. And now I have to apply these conjectures, these patterns that I'm seeing in these problems, okay? So here we have, the table shows the enrollment of incoming freshmen at a high school over the last 4 years. The school wants to predict, so again, you're going to make a hypothesis here, a conjecture based on patterns, the number of freshmen for next year. Make a conjecture about the enrollment for next year. So year 1, we had 258, and I want to know how much I jumped from year to year to year, okay? That's going to help me determine the pattern to determine how many possible freshmen we're going to have. So for this first to second year jump, we see 27 freshmen enrolled the following year more than the previous year. From year 2 to 3, okay, I see a 26 student jump. And then from year 3 to 4, I see a 25 student jump. Okay, so yes, these are all different. And I'm trying to figure out like approximately how many students will be here next year. Okay, so think about the pattern. So we have 27, 26, 25. Start thinking about those as we look at the multiple choice answers here. So enrollment will increase for about 25 students per year, or increase by 50 students per year, or decrease by 20 students per year, or stay about the same, okay? So there's two already that I can kind of cancel out already. I know that these did not stay the same, okay? So that's not going to be the last option. None of my numbers went down. In fact, they always increase. They're going up. So it's not going to be that one. So now it comes down to thinking about the average, okay? How many students does it go up by? An average. So yes, I know it's not the exact same number every time, but 27, 26, and 25, pretty close to 25 students. So I'm going to go ahead and select option A. All right, let's go to the next one. So number 8. Based on the table showing unemployment rates for various counties in Alabama, find a counterexample. So remember something about the table that we see that's not true, that will disprove the following statement. The unemployment rate is highest in the counties with the most people. Highest with the most people. So it's saying the more people there is, the higher the unemployment will be. Okay, so we need to use this table to see if that is true. And I'm going to go ahead and look at the highest unemployment rate. So I'm looking here. These two are going to have the highest unemployment rate. Okay, so I'm looking at 10.4 and 12.1. The other ones are under 10, so I'm not going to focus there. And then I'm going to compare this unemployment rate to the population. So is it true that the highest unemployment rate belongs to the county with the highest population? And I'm looking here. This would be my highest unemployment rate. Is this the highest population? Okay, well, no, this is actually a lower population than this county. So that right there is going to be my counterexample. So first of all, I'm going to say that this statement that they gave me is false. Okay, and then you want to provide that counterexample. So here I'm going to say that the county, the Perry County, has a higher unemployment rate but it has a lower population than our other county. Lowndes, maybe? Not quite sure. So that's going to be our counterexample there. Looking at the data in the table, this is telling us that that's not always true. The statement that they started us off with is not always true, and I gave a counterexample for it. All right, for this last problem, it says the table shows selected states, the 2,000 population of each state, and the number of people per 1,000 residents who are licensed drivers in each state. Based on the table, which two states could be used as counterexamples for the following statement? So again, we're looking for something that makes the statement not true. The greater the population of the state, the lower the number of drivers. So we're looking at population in increasing order compared to the number of drivers in decreasing order. Okay, so first I'm going to look at the population. Starting with the lowest population would be Vermont. The next one up would be West Virginia. And then we have, so that's this one, Alabama. And then Wisconsin, followed by Texas, and lastly, California. Okay, so we're trying to see if these would match the descending order of drivers, okay, per 1,000 residents. So starting off with my highest number that I have here for my drivers, the highest number I have is Vermont. So these match. That is a true statement, so this would not be a counterexample. The next number down would be Alabama. And that doesn't match West Virginia. It crosses this way, actually. So that is going to be one of our counterexamples because it's not matching directly there. Next one would be West Virginia. And again, same example there. it's not matching with the corresponding in population in increasing order. So that's going to be a counterexample. If we keep going, we have Wisconsin, and this one does match. So that's not going to be a counterexample, followed by Texas is the next lowest number, and that does match. And lastly is California, and that one is going to match as well. Okay, so our two counterexamples are going to be Alabama and West Virginia, because those were the only two that were misplaced, that were out of order, and are not following this pattern that is given in the problem.